Hello everyone, my name is Devasis Padik. Today we will discuss the second year subject computer organization, and today's topic is decoder. In the last class we have already discussed about the fundamental concept of your decoder and 2x4 decoder, the truth table and the circuit diagram. Today we will discuss some more concepts of your decoder. So let us first review the previous class concept. What is generally decoder? So the combinational circuit that changes the binary information into 2 to the power n output line is known as decoder. Okay? And in decoder, it works the opposite of your encoder. And in decoder, n input line and 2 to the power n output lines must be present. Okay? If n value is 2, 2 to the power 2, that is 4 output line must be there. If n value is 3, 2 to the power 3, 8 output line must be there. If n is equal to 4, 2 to the power 4, 16 output line must be there. Okay? So this is the block diagram of your decoder. N input lines and 2 to the power n output lines. So in 2 to 4 decoder, A0 and A1 are the two input lines and E is the enable line. Y0, Y1, Y2, Y3 are the output lines. And we know that at decoder at a time only one input is active. Okay. So this is 2 input and this is the enable line. This is the 4 output lines Y0, Y1, Y2 and Y3. And this is the truth table of your 2 to 4 decoder. These are the logical expression and this is the circuit diagram. This much thing we have already discussed in the last class. Today we will discuss another type of decoder that is known as 3 to 8 line decoder. 3 to 8 line decoder means in this type of decoder 3 input lines are there and 8 output lines are there. Okay, 3 input lines and 8 output lines must be there. The 3 input lines are A0, A1 and A2 and 8 output lines are Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Why 3 to 8 line decoder? And here the number of input line is 3 and number of output line is 2 to the power n, that is 2 to the power 3 is equal to 8. This circuit has one enable line input E, just like your 2 to 4 line decoder. When enable line E is set to 1, one of these 4 outputs will be 1. Okay? If enable line is active, the decoder will be work. If enable line is deactive, the decoder does not work properly, or you can say that the decoder is not working. Okay. So this is the block diagram of your 3 to 8 line decoder. A0, A1 and A2, these are known as my input lines and these things are known as my output lines. This is the truth table. If enable line is 0, whatever the value of A2, A1 and A0, the output is 0. That means the decoder is not work. When enable lines are 1 and if all the inputs are 0, since binary 0 and decimal 0 both are equivalent, Y0 line is active and Y0 line is 1. If A0 is 1, A2 is 0, A1 is 0, this is 1, so Y1 is selected. If A2 is 0, A1 is 1, A0 is 0, this is binary 2, so Y2 is selected. If A2 is 0, A1 is 1, A1, A0 is 1, this is decimal 3, so Y3 is selected. If A2 is 1, A1 is 0, A0 is 0, this is decimal 4, so Y4 is selected. If A2 is 1, A1 is 0, A0 is 1, 101, this is decimal 5. So Y5 is selected. If A2 is 1, A1 is 1, A0 is 0, 110, this is decimal 6. So Y6 is selected. If A2 is 1, A1 is 1, A0 is 1, this is nothing but decimal 7. So Y7 is selected. So from this truth table, if we derive the expression, Y0 is nothing but A0 prime, A1 prime and A2 prime. Because Y0 is 1 whenever all the values are 0. A2 prime, A1 prime, A0 prime. Y1 is equal to A0 into A1 prime into A2 prime. This is Y1, A2 prime, A1 prime, A0. And Y3 is 1, so A2 prime, A1, A0. Okay, 0 means prime. Y4 is equal to A2, A1 prime, A0 prime. Y5 is equal to A2, A1 prime, A0. Y6 is equal to A2 prime, A1 prime, A2, A1, A0 prime. And Y7 is equal to A2, A1 and A0. Okay, so this is the logical expression of the 3 to 8 line decoder. From this logical expression, I will draw the circuit diagram. Okay, so this is the circuit diagram of your 3 to 8 line decoder. Then 4 to 16 line decoder. Here 4 input line is there. So 2 to power 4, 16 output line must be there. Okay, so in the 4 to 16 line decoder, there is a total of 16 output lines, that is Y0 to Y15, not 16. This is 15, Y15. And 4 input lines are there, A0, A1, A2 and A3. The 4 to 16 line decoder can be constructed using either 2 to 4 decoder or 3 to 8 decoder. There is the following formula used to find the required number of lower order decoder. Required number of lower order decoder is M2 divided by M1. Here M1 is equal to 8 and M2 is equal to 16. So 16 divided by 8 to 2. So number of 3 to 8 line decoder required is equal to 2. Okay, 2, 3 to 8 decoder constitute 4 to 16 decoder. Okay, so this is the truth table. Okay, whenever A3 is 0 and this value are different, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. This is first combination. Then when A3 value is 1, this is the another combination, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. And following, and these are known as my output lines. Okay, first Y0 is selected, Y1, Y2, Y3, Y4, Y5, Y6 like this. Okay, so from this truth table, I will derive the logical expression and the circuit diagram. Okay, so this is all about your decoder.